Okay, so now we go to the second portion of this course, oxygen and bioinorganic chemistry. As we just learned in the first segment that bioinorganic chemistry is the reason why oxygen comes to this earth, and then we learn how bioinorganic chemistry itself played a key role to control that oxygen. So first, why oxygen is bad? Now oxygen is a strong oxidizing agent, so it can get reduced to oxidize others. So oxygen get reduced by 4 electron process. In the first section, it can get reduced to the superoxide ion, and this superoxide is a very nasty oxidizing agent, much stronger than the oxygen itself. In the second part, this superoxide can get reduced with the other 2 protons involved over there and produce that hydrogen peroxide, which itself again a oxidizing agent. Then hydrogen peroxide reacts with another electron and produces hydroxyl radical. So far we produce from oxygen to superoxide, H2O2 and hydroxyl radical, and all of them itself are oxidizing species, and all these things together known as reactive oxygen species or ROS. And at the last step, the hydroxyl radical get reduced and produce the benign water at the end. So over here you can see the oxygen not only itself can be a good and strong oxidizing agent, but it produces a number of reactive oxygen species, superoxide, hydrogen peroxide, hydroxyl radical, and all of them can actually affect detrimentally to the biology. Especially most of the framework of the biology like the protein, the lipid, the DNAs are actually in reducing atmosphere. So all these reactive oxygen species can react with that and break them down. So it can actually break down the core of the biology. So that's why oxygen was very bad in the beginning, because it affects our systems. So now biology itself produces the solution. Over there are enzyme called superoxide dismutase. As you can see it over here, this is the structure of the superoxide dismutase, and over there if you look closely, other than this protein atmosphere around, there is an active site where we have 2 elements, and both of them are inorganic element, copper and zinc. And this particular superoxide dismutase, and we call them copper zinc superoxide dismutase, obviously because of the elements they have in their active site, they react with superoxide and produces H2O2 and oxygen through a dismutation or disproportionation reaction. That means this superoxide dismutase enzyme react with superoxide ions, one of them get oxidized to oxygen, one of them get reduced to H2O2, and by that they actually take care of that harsh superoxide ion in the biology. However, during this system what we found that in biology that is not the only superoxide dismutase what actually get evolved. There are iron, there are manganese, and there are nickel superoxide dismutase are also present, which can do the similar reaction and get rid of the superoxide ion. Although this superoxide dismutase is fine and act as the first line of defense system to counteract the superoxide, it still produces hydrogen peroxide as their side product, which you already know itself another strong oxidizing agent. So that means that superoxide dismutase only make the system a little bit better, but didn't provided the full solution. The H2O2 is still available. So biology evolved further and produces this enzyme called catalase. Again, in the catalase, if you look into the active site which is surrounded by this protein atmosphere, we found this iron bound system which is known as a iron porphyrin or heme system. We will discuss the details of the structure a little bit later part in the next segment. Over here what we found, this iron bound catalase enzyme can also react with H2O2 and produces again a disproportionation reaction and produce water and oxygen, one part reduced, one part oxidized, and by that it can remove the toxic H2O2. That means biology has the tools to counteract the superoxide and hydrogen peroxide and get rid of them. Over here biology got a little bit adventurous. They found, okay, I can handle the toxic H2O2, but what I am producing, water and oxygen, none of them are really useful for biology. So biology thought, we have the H2O2 present there which is an oxidizing agent, can I handle it properly and use it for our own good? and oxidize some of the bioelement during the biosynthetic process. Use H2O2 as an oxidizing agent, but in a controlled manner, and here develop this enzyme called peroxidase. Over here the peroxidase also has a similar iron porphyrin system, but over here instead of doing a dismutation reaction like the catalase, it actually reacts with two substrate molecules and produced oxidized substrate molecule while producing water from the H2O2. So that means it is not only taking care of the strong oxidizing agent H2O2, but at the meantime they are also oxidizing some of the biomolecules. This peroxidase enzyme are very crucial for producing some very important oxidized biomolecules like hormones in the biology. So this peroxidase is another nice example of bioinorganic chemistry, how it helps us to get us our defense system against the reactive oxygen species. After biology found that okay, I can use H2O2 and use it in a controlled way to oxidize some organic matters, then biology thought, can I even use the oxygen itself instead of using hydrogen peroxide, because the production of hydrogen peroxide means the oxygen first has to react with something getting oxidized and itself getting it reduced to superoxide and then comes to H2O2. Biology found a new way to use the oxygen itself, and for that they actually evolved with this enzyme called cytochrome P450, which is again a porphyrin based system with iron, and over there that oxygen itself can be used directly and we can use its oxidizing power to oxidize some of the organic molecules. By that what we can say that the oxygen, which was first a poison to us, which was degrading ourselves, the biology, the bioinorganic chemistry not only provide us the solution how to handle it, but it also allow us how to use the oxygen for our own purpose and use it for biochemical pathways. And this peroxidase enzyme is very crucial because most of the pharmaceutical molecules we intake, including the paracetamol, it actually get oxidized first during its reactivity in our system, and that oxidation actually occurs with the help of cytochrome P450, which actually use oxygen, the oxidizing agent. And over here I am showing you a picture where this is the full structure of the cytochrome P450. Here is the heme system, and over here in the dotted line I show you erythromycin, a drug molecule. So that actually get oxidized with the help of cytochrome P450. So over here in this particular segment what I found that oxygen is actually nasty, it is detrimental for biology because it produces the reactive oxygen species, superoxide, H2O2 and hydroxyl radical. However, the biology itself provides a solution how to tackle them. They provided us superoxide dismutase enzyme, which actually degrades the superoxide to H2O2 and oxygen in a disproportionation reaction. Then it provides the enzyme catalase, which actually degrades the H2O2 to water and oxygen. Then a variation of the catalase with respect to the active site, peroxidase came, which actually not only degrading the H2O2 but oxidizing some organic molecules in the pathway. And at the end we got the cytochrome P450, which actually uses the oxygen itself as the oxidizing agent and use it in a controlled reaction. So altogether we can say this bioinorganic molecules provided us the solution for the problem of the oxygen and make it a not only a solution but a lifeline for us at this moment. So over here I also like to mention, if you look very closely, all these heme proteins which are actually very similar looking, the very important difference is what is actually bound as the axial ligand to this iron. In catalase it is actually a tyrosine molecule, in peroxidase it is a histidine, and over in cytochrome P450 it is a cysteine. We will come into a little bit later how this coordination geometry plays a crucial role controlling the reactivity of this active site. So over there we will conclude the segment 2 of the bioinorganic chemistry.